Welcome to YouTube channel scientific underscore math. We are solving a system of linear equation using Gauss elimination method, and in earlier lectures we discussed Gauss elimination method, MATLAB code for Gauss elimination method, Gauss elimination method with pivoting, MATLAB code for Gauss elimination method with pivoting, Gauss-Jordan elimination method, and MATLAB code for Gauss-Jordan elimination method. I will provide the link in video description of all these lectures you can watch, and here we are going to learn about Gauss-Jordan elimination method with pivoting, and in next lecture we will write a MATLAB code for the Gauss-Jordan elimination method with pivoting. Okay, so what is pivoting? We have already discussed in this lecture Gauss elimination method with pivoting. Why we need to do pivoting? So in this lecture, we will again discuss about the pivoting. Why we need do pivoting in our Gauss-Jordan elimination method and during the procedure of Gauss-Jordan elimination method. So let's move toward lecture, and here we have a Gauss-Jordan elimination method with pivoting. Okay, so in Gauss-Jordan elimination procedure, the pivot equation is normalized by dividing the equation or row with the pivot coefficient. Okay, so in Gauss-Jordan elimination method, we have already learned about the normalization. What is the normalization? Normalization is this. For example, we have this is the pivot equation, and this one is the pivot element. To normalize in this pivot equation, we divide this pivot equation by the pivot coefficient. This is the pivot coefficient, and to make the pivot coefficient 1, we normalizing. Okay, so here we can see that the pivot coefficient is 0. So when 0 comes in the denominator, and this will undefined. So and due to this this problem, we do pivoting. We exchange this row with the row that has non-zero pivot element. Okay, so here this is however cannot be done if the pivot coefficient is 0. We have seen this one. Okay, so for example we have this example, and this one is the pivot row, and this is the pivot coefficient. Okay, so as the first equation is the pivot equation and 0 is the pivot coefficient, and so we cannot normalize we normalize the equation or the row. The division by the 0 can be avoided if the order in which the equations are written is changed such that in the first equation the first coefficient is not 0. So we change the order of the equations by which whose first element is not 0. For example, this one we change the order, and this will come first and this will be on second position, this equation. Okay, so this is the pivoting. So next we have an example, and first we write in this equation this system of equations Ax is equal to b in matrix form, and here we have augmented matrix. So we write it in this is this one and this one as a augmented matrix to apply the Gauss-Jordan elimination method. We have already learned this one in previous lecture. Okay, so this is our augmented matrix, and here we can see that, and this is this is the row that is pivot row or the pivot equation, and we want to normalize this. So here the first coefficient, the coefficient of pivot coefficient is 0. So first we do pivoting and then we normalizing this row. So we change the order of this equation. The pivot equation 1 as a zero pivot element. So exchange with the row 2. Okay. So after pivoting, and this will be okay. This will be 4 minus 3 2 and 16 0 2 3 and 46, or this will be as it is 4 minus 3 and 12. Okay, so next we divide this equation and this pivot row by the pivot coefficient to normalize this, and here we can see that divide the pivot row 1 with the pivot element 4 to normalizing the pivot row. Okay, so we have a normalized pivot row. Okay, so next this is already 0, and now we eliminate this term. So we multiply the pivot row with 2 and subtract from the third one. So this means r3 minus 2 times r1. So this will be r3. Okay, so multiplying row 1 with this 2 here will be 2 and subtract from the first we do this one and then we go to what this one. So multiply with 0 and subtract from 2. Okay, so this will be again same as it is. Next we multiply this one. Okay, here we can see that multiply row 1 with 2 like this one and subtract from the third row. So after doing simplification, we can see that this is now eliminated now. Okay. So in next we have this one is the pivot row. This is the next pivot row, and we will normalize this row by dividing by pivot coefficient. So pivot row divided by pivot coefficient is 2. So divide the pivot row 2 with pivot element 2 normalizing the pivot row. So here we have a 1 normalized pivot row. Okay, so now we eliminate this one and this one. So we multiply r2 with a minus 3 by 4 and subtract from r1, and this will be equal to r1. So this will be updated now. Okay, so this one and subtract from, so this is eliminated now, and now we eliminate this term by multiplying by r2 multiply with 11 by 2 and subtract from r3, and this will be equal to r7. So this is now eliminated. So we do pivoting always. First we check is in the pivot coefficient, is the pivot coefficient is 0 or non-zero. In this case we also see if the pivot coefficient is 0. So what we do, we exchange the order of the rows. Okay, so in this case the pivot coefficient is again non-zero. So what we do, we will now normalize this pivot row by dividing the pivot row by pivot coefficient. So divide the pivot row 3 with the pivot element this one. Okay, to normalizing the pivot row. Okay, so now this is normalized, and now first we eliminate this one and secondly this one, first and second. Okay, so what we do, we multiply r3 with 3 by 2 and subtract from 13 by 8, sorry, 13 by 8 and subtract from r1. This will be equal to r. So now we can see that this is eliminated now. So next what we do, we multiply 3 by 2 with r2 and subtract from sorry, multiply with r3 and subtract from r2, and this will be equal to r2. Okay, so all these terms are eliminated now. Okay, so this is the reduced echelon form, and now uh, we can write this one as a x is equal to b in this form. So this will be equal to x1 will be 5, x2 will be 8, and x3 will be 10. Okay. So thank you so much for watching my video. Please subscribe my channel scientific underscore math, and in next lecture we will write a MATLAB code for Gauss Jordan elimination method with Revit.